So, good morning, dear friends. Myself, Dr. Ligraju, Assistant Professor of Physics, Government First Degree College, Tumkur. Our college is affiliated to Tumkur University. So, today we will discuss in BSc 4th semester of Physics subject, session number 19, that is a acoustics of building and reverberations and time of reverberations. So here, last class what here we are going to discuss from a sound, different kinds of a sound, resonance, Fourier transformations. So we are going to next discuss a reverberations of buildings. Here we know, in the previous class we discussed resonance. So the resonance is completely related to this chapter. So far, just here we are going to glance the last class of resonance concept. So resonance means natural frequency is matches with the artificial frequency. Then here we are getting a very maximum sound. That is we call as resonance. So in the practical based how we are going to observe or identify, I will give you one example. So we are regularly listening some FM radio stations. So FM radio station, they maintain certain amount of a frequency range. For example, 98.7, 100.1, 97.3. So like that, the different frequency range of a FM radio stations are there in Bangalore. So they are fixing their own frequency ranges. If we take in our instrument, radio, so tune the frequencies. If the variation of frequency, for example, 98.3, one station name. So we are going to give a tuning of this frequency 98.5 from the starting of 98. So if you put a 98 initially, so we are getting a very small sound, and also it is with a very small disturbance. So 98.1, it is going to decrease the disturbance. 19.2, similarly it is going to decrease the 98.3, we are getting a maximum sound. There is no any kind of a disturbance occurring in this particular frequency range of relations. Why? Because of, so they are maintained the frequency 98.3, it is matches with our radio frequency. So it means these two frequency will be matches at a particular point. At that point is we called as resonance. So that is we called as natural frequency matches the artificial frequencies. Both are matching. Once again, you increase the frequency from the 98.3, 98.4. So the disturbance will be going to increase. 98.5, the disturbance will be going to increase too much. So like that, the audio is going to decreases. The disturbance is going to increases. So at a particular point of view, here we are getting a maximum. So there is a resonance. After knowing this resonance, now here we are going to discuss some concepts of acoustics of buildings. Acoustics of building. So initially, acoustics of buildings with the generation, propagation and occupation of sound. It is going to divide into, once again, three different kinds of sounds. That is musical acoustic, electroacoustic and architectural acoustic. So first one here we discuss musical acoustics. It deals with the designing of mutual instruments. Second Second one is electroacoustics. It deals with the various methods of producing and recording sound. That's the second one. Third one is architectural acoustics. It deals with the designing and construction of buildings and auditoria with respect to the behavior of the sound waves. So like that here we are going to discuss. Now the reverberation and reverberation's time, how it is going to take place. So here, now here, what here we are going to discuss first musical sound. The sound which produces a satisfying effects on the human ear is named musical sound. It consists of a regular periodic vibrations. You see, we can observe. So if the sound will becomes regular, the wavelength, the frequency will be completely uniform. Here, if we talk, it is nothing but noise. We can observe the noise is having a different frequencies, different wavelength. So it is different. But here the time and amplitude remains constant, that is called as musical sound. So the musical sound consists of a periodic variations in frequency, intensities. There is no sudden and huge change in intensities. Sounds produced by a violin, a piano and organ pipe are musical sounds. Organ pipe are a musical sounds. So next, the following are the three characteristics of the musical form. One is pitch. The feeling of the shrillness produced by a note is understood as pitch. The feeling of a shrillness produced by a note is understood as a pitch. This sensation depends on the frequency of the incident sound and also independent of the loudness or quality. And also it is independent of the loudness or qualities. So second characteristic is loudness. We know loudness. Loudness is that of the degree of sensation of sound. Is jora ನೀವು ವಾಯ್ಸ್ ಮಾತಾಡ್ತೀರಾ ಡೌನ್ ಮಾಡ್ತೀರಾ, so it is going to decreases or increases. Degree of sensation of sound produced within the ear of the listener. So it depends on the intensity of the sound and sensitivity of the ear in the listener. So here, if it comes sound in uniform order, but listeners the sensitivity will be difference means, so at the time the loudness will be going to variation takes place. If one person is listening with a very sensitive order means they can get a very hard or huge loudness, but they are having some problems in the ear, so you are hearing very less sound. So here we are getting a different kinds or different degrees of sensations. So it means finally it depends on the intensity of the sound and its sensitivity of the ear to the listeners. Third characteristic is quality or timbre. Timbre in general term is distinguishable characteristics of a tone. Distinguishable characteristics of a tone. It depends on the presence of overtones. Quality differentiates between two sounds halves the same loudness and pitch. Same loudness and pitch. So that is the characteristics of the musical sounds. Next is acoustic buildings. Acoustics of buildings. So acoustics of buildings. Acoustics deals with the generations, propagations and receptions of sound. It broadly discussed are divided in three different types. One is musical acoustic, second one is electroacoustics, third one is agricultural acoustics. Agricultural acoustics. So musical acoustics deals with the designations of musical instruments, designing of musical instruments. Electroacoustics deals with the various methods of producing and recording sound. Then architectural acoustics, it deals with the designing and construction of buildings and auditoria with respect to the behavior of the sound waves. It is going to changes with respect to change the behavior of the sounds with respect to the area, mob, and also vacuum. Everything is going to change state space. You see, this is acoustic room. How to maintaining a rebound of the sound? So they are going to maintaining so many different kinds of items. See, so these are all maintains are avoiding the reflections of the sounds. So it's about this one. Then reverberation and reverberation time. So reverberations is consider one auditorium in which sound waves are produced. An observer in the we can observe here. An observer in the auditorium receive two types of sound waves. One sound wave directly from the source of sound, and the other sound wave reflects from the surface in the auditoriums. So you will do very important. One will be directly, it is come from the instrument. Second one is it is going to incident to the walls of the room and it gets reflected. These reflected sound waves will be going to listen once again. Like it means the sound or the music comes in two sides or two types or two ways or two types. Then these two sounds waves are received by the listener with a certain time gap. Initially direct sound will be reaches, then after some few microseconds the second sound will be going to listen here. So then it can be noticed that the sound persists in the auditorium for some time even after the source of sound stop producing the sound waves. It means if they having a gap means after completing or after stopping of the sound also, so we are going to listen some sounds. So there is the reverberations of time. So that one is here we can going to observe it. This persistence of audible sound in the auditorium is called as reverberations, and the time during which sound persists in the auditorium is called reverberations time. Next, we are going to define these two separately. Reverberations, the persistence of audible sound in a hall or auditorium even after a sound of a source of a sound stop emitting sound waves is called reverberations. The time during which the audible sound persists in the hall or auditorium even after the sound of a sound stop emitting sound waves is called as a reverberations times. ಹಾಗಾದರೆ ಇವು ಏನಕ್ಕೆ ಇದು ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ? So we will discuss. Reverberations time is completely depends upon the nature of reflecting materials on the walls, ceiling, roof, floor, etc. So ಈಗ ನಾವು ಅಲ್ಲಿ ಯಾವ ಥರ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಯೂಸ್ ಮಾಡಿರ್ತೀವಿ. ಸೊ ಫ್ಯಾನ್ ಇರುತ್ತೆ, ಸೀಲಿಂಗ್ ರೂಫ್ ಇರುತ್ತೆ, ಆಮೇಲೆ ವಾಲ್ಸ್ ಇರುತ್ತೆ, ಆಮೇಲೆ ವಿಂಡೋಸ್ ಇರುತ್ತೆ, ಸೊ ಫೋಟೋಸ್ ಇರುತ್ತೆ. So like that. So these are all having a different criteria, different nature of a reflection of sound waves. The frequency of a sound emitted in the hall. So how much frequency of a sound will be going to incident to a wall or window or anything. That reflection back. So it is going to depends. Third one is the coefficient. The coefficient of these absorption materials present in the hall. So ಇಲ್ಲಿ ನಾವು ಸೌಂಡ್ಸ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕೆ we are going to maintain some materials. So it is going to observe the sound to maintain, to avoid the reverberations. For that purpose how many number and how what quality and what type are we are going to maintain based on the coefficient of absorption material present in the hall is also the reverberation time is depends. The volume of the hall or larger the room or larger is the reverberation time. You see, if the how much size of the room, how much area of the room. So if the room area will be big means the reverberations sound and also the time will be going to variation takes place. And also to maintaining all the different kinds of absorption coefficient materials, so it is going to avoid the reverberation sound and also with respect to the time also. So the intensity of the sound waves emitted in the hall. So how much intensity of the sound will be comes out from the instrument is incident on a different materials, then it gets reflected back. So how it get reflected back in a different conditions. Based on that, here we are going to observe the variation of reverberations times. Knowing this one, so we can easily avoid any kind of a materials of the reverberations coefficients. So that is a reabsorption coefficients. Reverberations time depend upon a coefficient of absorptions. Coefficient of absorptions. A greater the absorption coefficient, the less will be the reverberations times. ಅಲ್ಲಿ ನಾವು ಎಂತೆಂಥ ಮೆಟೀರಿಯಲ್ಸ್ಗಳನ್ನ ಸೌಂಡ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಎಕೋ ಬರೋದಕ್ಕೆ ಮೇಂಟೈನ್ ಮಾಡಿರ್ತೀವಿ ಟು ಅವಾಯ್ಡಿಂಗ್ ದ ಎಕೋ, ಸೊ ಇಟ್ ಲೀಡ್ಸ್ how much amount of a reverberations time will be comes out. So that is a very important point. The absorption coefficient of a surface is defined as the ratio of sound energy observed by the surface in a given time to the observed by a perfect observer, such as an upon window of equal area at the same time. An upon window is a perfect observer because it reflects no sound at all. So based on this concept, here we are going to observing the reverberations sound and also times. So similarly, here we are going to maintaining in a room to avoiding the echo from getting a reverberation there. So absorption coefficients. To maintaining a more absorption coefficients, so we can avoid it. The reverberations sound also at times. So next, for this concept, I was collected so many different kinds of books and referred them, prepared the notes and also PPTs. So first is Sundarajan book. Sir is written in a United Publishers. Name the book is College Physics. Like that, Subramaniam. It is a very good book. Chand Publishing is published Sir book in the name of the textbook of optics. And also the 3, 4, 5 and 6, 4 members are assistant professors of physics in a Tumkur University, different colleges. They are written a prescribed textbook. One is Mangala Gauri, name is undergraduate physics. Next is Nagbhushan. Sir is also written a book in the name of Handbook of Physics. And also Ramakrishna Ji. And we are also going to observe the slide shares. So through this one, can also get it here. All these, and also can observe so many different kinds of materials in this area also. So it's about this topic of sound, that is required acoustic of buildings, reverberations and the reverberations time. Next class, so knowing this sawtooth wave intensities and loudness of a sound, so we are discussing these acoustics of building, reverberations and reverberations of time. So next class we will discuss based on this one. So derivations of Sebre's formulas, so requisites of its the reverberations times, and also the different kinds of requisites of a good acoustics. So we discuss all these things. Thank you one and all.